Hello everyone. Welcome to the second part of this technical video on how to achieve faster analog design closure with early parasitic analysis flow. In the first part, Denis highlighted the pre-layout parasitic estimation and planning. Designers can estimate resistance and capacitance from routing specifications or extract from partial layout using signoff RC engine, and then use prime wave design environment to easily control which parasitics are included for their pre-layout simulation. In this session, Denis will show you how you can avoid unnecessary layout iterations by checking and fixing resistance and capacitance directly on canvas during layout with sign-off engines. Denis will also introduce you to our new and exciting partial layout extraction and simulation flow. Off to you, Denis.
Now let's go ahead and talk about how do you use the same engines, which is the InDesign resistance capacitance engine with a star C functionality to really help optimize your layout according to the budget that you would have had to start with. I'm going to start by talking about a few customer examples that we've encountered over the years of rolling out a functionality and deploying it to customers. So here, for instance, we worked with a microcontroller team. They had specific requirements for analog PG nets, and they were using initially manual calculations. So we replaced those manual calculations and spreadsheet with the functionality in custom compiler, which helps them be more efficient and more accurate using Foundry files, again, Foundry certified process model files. Another example here is a graphics chips design team. They use the InDesign solution to be able to get a first level assessment prior to running the sign-off extraction and timing analysis. And so they would use the InDesign capability to have a first level assessment and close the gap faster between their implementation and the validation. And then analog IP, a couple of different examples here. They would identify high coupling capacitance between nets that are key, but they are right too close to each other, and then by using the InDesign capability, avoid having crosstalk issues later on. And then another example here, as an analog IP, you have matching pairs. You want to make sure that the load is balanced between the nets of that matching pairs. And finally here, as another example, high voltage industrial automotive chips. You may have a complex PG mesh, and you can't really rely on sign-off tool as much for point-to-point calculation because you don't have pins within the mesh to hang on to. And so the capability within the custom compiler is useful from that standpoint, where you can prepare queries on coordinates, specific location into your mesh, and then check the resistance between branches of your mesh. So moving on to the use model, it's available within the layout editor. You'll have the ability to then get a breakdown of the contributors of both your resistance and capacitance, and really fine-tune your analysis of your interconnect to really improve and optimize your layout with respect to your goals for electrical characteristics of your nets. All right, and that is being done again with the star C engine. So you would be bring up the layout editor. On the left side of the layout editor, you have the design navigator, which is your interface to the logic in a design. So all of the nets are listed there. You'll be selecting one of them or several of them. We also support running calculation on multiple nets at the same time, and bring up the report resistance or report capacitance interface. And then from then on, if you're calculating a resistance enter the point, you get the resistance calculated, and you have the breakdown. From there, you can cross-probe to the layout directly, and then proceed with your analysis and your optimization of the layout. The other thing is that we have the ability to save the queries. So you want to reuse a query that you've specified, which is very useful when you are doing instance to instance terminal queries. You can move instances around and recalculate. And then similarly with the bash tickle, that allows you to reuse the queries you've saved, as well as script the calculation. The InDesign capacitance reporter use model is very much similar. You bring up from the design navigator. You have the net. No need to enter any point. Just run on the net, and then you'll get the information about your capacitance, your coupling capacitance, and when you select one of them here, as I did here, I selected the coupling capacitance, you'll get a breakdown, and from there on, cross-probe to your layout. the parasitic reporter is also aware of design intents that the designer may have passed on to the layout team. The design intent is visible into the constraint editor. Here, for instance, I have a constraint of 1 femtofarad, and the way it's going to be used by the tool is by the resistance checker or the capacitance checker that you can run from the constraint editor. You can also run a checker from the design navigator itself on the net that you've selected there. In the constraint editor, it gives you the fail-pass criteria, and then in the parasitic reporter, it will also give you a visual cue about whether it's passing the constraints or not. With the constraint information. Now let's go ahead and proceed with the demonstration. All right, so I've opened the design already, which is in this case an amplifier, and we'll go ahead and bring up the layout with the SDL mode. The SDL mode helps to maintain consistency between schematic and layout, and also have full connectivity information into your layout, which really helps with your parasitic analysis, because then you can leverage the logic from the schematic and the mapping to the layout to be able to set your queries and also prepare your constraints. So here I brought up the parasitic reporter. You see I'm set the star C engine to perform the calculation. And I'm also using the star C process files that which you typically get from the foundry on the target process node. In this case, I'm running actually the resistance calculation on the net without specifying the source and destination. And what it's going to do is that it's going to look for all of the pin-to-pin or instance terminal-to-instance terminal combination on that net and produce a report. And as you can see, it did a color, the results, some in red, some in green. The reason is that there are constraints on every one of these instance terminals. And my goal is really to have a balanced branches for that net and have everything within 600 ohms. And as you can see, I can sort all of the contributors of each one of these calculated resistance values, so I can review which wire has the highest resistance. So let's go ahead and see if we can improve the solution. And what we see actually looking at the layout is that the network is open. We have some gaps in the wiring, and by closing the gaps, we'll actually have more parallel resistance, which will reduce the overall resistance of the wiring. To close a gap, I'm using the interactive router, which is also available in the custom compiler layout editor, which is another great tool for layout productivity. So I went ahead and closed the gaps. I have more parallel wires here, and I should see the impact on the resistance right away. So I'm rerunning on the net. I get all of the pin-to-pin combinations listed. Everything is green, so I'm good to go. Let's move on to look at the use of the capacitance reporter. And what I'm using here is a pattern route assistant. It's a FinFET design, and as you know, FinFET instances have a lot of instances in the layout, and they're arranged in arrays. And so the pattern route assistant really helps to route those instances very quickly by choosing the pattern that you want to apply. So let's go ahead and run a capacitance analysis here. And you saw I got about 4.27 femtofarad on that net before I routed the second net. So I'm writing the VINP. So I have both VINP and VINM routed now. And you'll be able to run capacitance calculation on both of them at the same time and see how one impacts the other. So my capacitance on VINM actually increased to 4.45 and is marked as red as it violates now the capacitance constraint that I had entered in the constraint editor. So the design intent from the designer is being violated. I can, of course, review the contributors to that capacitance. And next, I'll try and see if I can change the layout in order to improve the electrical results that I'm seeing here. One way to do that is to reduce the overlap, the lateral overlap between the two nets. And so maybe a different pattern for the routing of one of the nets will help with staggering the wire and reduce the coupling capacitance between the two nets, and then bring down the total capacitance. I can quickly rerun the calculation, and as you can see, everything was green. All right, so that concludes the demonstration of the InDesign RC parasitic reporter in the layout editor. I'd like to recap again. You've been able to see the parasitic estimation that helps close the gap between design and layout. Once you have a layout, you're able to update those parasitics. But how do you get to a wiring that honor the budget that was determined by the designer? You use a parasitic reporter, and that gives you a really powerful tool during your layout implementation to really optimize the wiring and nail down the wiring to honor the design intent. Now let's go into the next couple of slides here. I'm going to talk a little bit about the partial layer extraction. It's a new functionality that we are rolling out as well this year that's going to help you in a couple of different ways. First of all, it's going to rely on the signoff flow, IC validator and star-RC signoff flow, to be able to bring to you an SPA file you can run simulation on. It's going to make use of SDL to identify what did you place in the layout already, what did you route in the layout already, and what is not in the layout yet. And using the schematic netlist and the extracted netlist, merge the content into a single netlist that you can run a simulation on. The benefit of that is that, first of all, it's going to perform the extraction of all of the nests that you have already laid out. And then second of all, you can start using this flow right from the device placement. You will be able to get the effect of the device parameter from the signoff extraction, the ICV LVS runset part. So that's very, very useful. And you can see that in this example that illustrates the point. We've run here on a design of place layout, partially routed layout, and you can see the impact here again on a frequency from the parasitics extracted by the signoff tool using this flow. While in a traditional flow, you may wait until 1 week until you complete the layout to get the effect. In just a matter of hours, you may have been able to place it. You can experiment with multiple placement and see how it affects your design. I invite you to go to synopsys.com/custom webpage and take a look at this webinar that we did with Michael Lynch, who is a director of one of our IP design team. Great, so thanks a lot for attending the presentation today using this capability in the Synopsys Custom Design platform, custom compiler, parasitic estimates, custom compiler InDesign RC using the star-RC engine. You really have the tools at hand now to reduce your iteration and close the gap between pre-layout and post-layout simulation, in particular for your advanced nodes need. With that, I'd like to thank you for attending the presentation, and we'll address your questions in due time.